going to see how we can use inverse matrix to solve a system of equations. We'll do a 2 by 2, and then the 3 by 3 would be the same exact thing. I don't think your notes get into a 3 by 3, but it's the same kind of approach. So you prefer same slide or a new slide? But, oh, by the way, these slides too, I could email them to you later.
Oh, yeah.
Yeah, so not only you can have the video, you can have the slides. And I could share them with you and whatever you like to do. So you want it on a separate slide?
Yes.
Let's do a separate slide. So we'll just add a page here. And let's show the ruled lines. Okay, so where was that equation that was on there? So using inverse to solve a 2 by 2 system of equations. Was it this one? Can you go to where they have the x and the y thing? Yeah, right there. Okay, so this is the question usually. 3x plus 2y equals 12. Okay, and x plus y equals 18 or 8. Okay, now we did before like how to do this using elimination and substitution. Right. The point of this is how to do it using matrix. Okay. So the first step is, step 1 is you write it in the matrix form. Okay. So step 1, write it in a matrix form, and I think I showed you that. Correct? Yes. So what you do is, this is coming straight from multiplication. You're going to have a 4 by 4 here, right? And you're going to have your unknowns here, x, y, and this is a 2 by 1 matrix. And then the answers go on a matrix on the right hand side. And what goes here, so you can get this, you're supposed to have 3 here, so that you can have 3 times x is 3x, plus, now since you're going to go down, you're supposed to have a 2 here, so that you can get 3x plus 2y equals 12. We did that. Okay, and then the coefficients that are here go here. So basically the coefficients on the x and the y go on the first matrix, then the x, y, then the 12, 8. Okay, and now, so this is how you recast the equations in the matrix form. Now the second step is, this is going to be your A matrix here. Okay, so let's, instead of keep writing this, let's write this in the matrix form to show you the point here. So you have A times a matrix X. So this is A. We're calling this X. Okay? And let's say that this is according to your, let's just call it the solutions, S. Okay? So watch what happens here. Let me use a different color on this. So here we have, look, A, matrix A, when I say A, I mean matrix A times X times matrix X, which is the XY, is giving me a matrix S. Okay? These dashes underneath mean matrix. Now, look what's going to happen here. I'm going to pre-multiply. Yeah, pre-multiply means multiply before. Because in math, technically, you can multiply an equation by any number and nothing changes. Except that since these are matrices, I will multiply by a complete matrix. So if I multiply here by inverse A on the left side, then that means I have to multiply here by inverse A. Right. Correct? Inverse matrix A. Okay. Now, what's A inverse times A? Just the identity matrix. So this gets you the identity matrix times matrix X, and that gets us A inverse inverse times matrix S.
And that'll equal matrix X, right?
And this will equal matrix X, which is my unknowns, the X and the Y. So this is equal matrix X equals A inverse times S, which means that to find my unknowns, all I have to do is find the inverse of this and pre-multiply it by 12.
Okay.
So we're going to find the inverse, which is what we were just doing, and then we're going to do the inverse multiplication, which is what we did last time. So we'll multiply two matrices by each other. So this is A, so we'll get the inverse. So should we do it here?
Yeah, we can do it though.
Okay, so 3, 2, 1, 1. You want to try, or you want me?
Why don't you do this one thing and I'll do one on the paper?
Sure. So 3, 2, 1, 1. So now this is matrix A. Okay? And so I will find the inverse now. Okay, so this is matrix A. Let's change the color. So we have 1, 0, 0, 1. Okay? And now I need to make this a 1. So like you say, I can either multiply row 2 by minus 3 and add it to row 1, or I could just simply say row 1 divided by 3. Just be quicker. So then I would get, let's change the color. So we would get 3 over 3 is 1, 2 over 3, 1 over 3, 0. And then the second row remains as is, 1, 1, 0, 1. Okay? And now this guy needs to be a 0. So that's easy. So I could just say row 2 minus row 1. Yeah? So row 2 minus row 1. And so let's do that. So then we get, so I need to change row 2. So the first row remains the same. So I'll just copy it. 1/3, 0. So row 2 minus row 1. So 1 minus 1, 0. 1 minus 2/3. I could do it here to show you. 1 is just 3 over 3. So this becomes 3 over 3 minus 2 over 3. So 1/3. So 1/3 goes here. Okay, and then 0 minus 1/3, minus 1/3. And 1 minus 0 is 0. Sorry, 1. 1. 1 minus 0.
Oh, right.
So 1. So there we go. Let's scroll down. Okay, so now we are here. Now this guy needs to be a 0. Correct?
Yes.
So look, this is 1/3, this is 2/3. The only way this can become a 0 is if this guy is minus 2/3. So when I add it to the 2/3, I get 0. So the question becomes, how do I make this a minus 2/3? Well, if I just multiply it by minus 2, then it becomes a minus 2/3. So that means I need to multiply row 2. Oh, I should put it on the first row. So row 2 by minus 2 and add it to row 1. Okay. So so then I will leave row 2 the same.
Right.
So 0, 1/3, minus 1/3, 1. And then minus 2 times 0 is 0, plus 1 is 1. So this one doesn't change. It's not supposed to. Yeah. Minus 2 times 1/3 is minus 2/3, plus 2/3, 0. And minus 2 times minus 1/3 is plus 2/3, plus 1/3. So 2/3 plus 1/3 is 3 over 3, which is 1. So this guy here becomes a 1. And then minus 2 times 1 is minus 2, plus 0, negative 2. Okay, one last step. So now all we have left is to make this guy a 1.
Divided by 1.
Or multiplied by
times
3.
3.
Yeah.
Probably easier.
Yeah. So then row 2 times 3. Or 3 times row 2. Okay, so let's change colors. So first row remains the same. 2/3, 1/3, 0. And this is just 0. Oh wait, I copied this one? Yeah, I did. Row 1 doesn't change, right?
Yes.
I miscopied. So 1, 0, 1, minus 2. Okay, so this 0, this times 3 is just a 1, and this times 3 is just a minus 1,
right.
And this times 3 is just a 3.
Yes.
Okay. So this guy right here is A inverse.
Okay. So now we do A inverse.
You agree?
Times, yes.
So now back to the original note, all we do is A inverse times S, which is the 12/8, and then we get the answer. So okay, so then our x, y, remember because matrix X was xy, is equal to A inverse,
right, which is equal to
times S. So this is equal to this, 1 minus 2 minus 1, 3. Times, what was it? 12/8?
Yeah. Yep.
Yeah, 12/8. Okay. So if you remember from matrix multiplication, it goes 1 times, oh, by the way, this is a 2 by 2,
yes.
and this is a 2 by 1, so we can multiply. And we're going to get a 2 by 1, so we're going to get one just like that, which makes sense because one of them, the top one will be x, the bottom one will be 1. So xy equals 1 times 12, yeah, I read the steps, so in case, plus minus 2 times 8. This is all in one cell, okay?
Yes.
So that gets us the top one.
So,
and then minus 1 times 12 on the bottom one.
right.
So we go, you know what we're doing, right?
Yes, sir.
We go row,
Right.
column,
Yeah.
and then we're going to go row,
column.
column.
Yes.
So minus 1 times 12 plus 3 times 8. And this is, of course, a matrix.
Right.
And so now we're going to get as our answer xy equals 12 minus 2 times 8 is minus 16, so that's minus 4.
Right.
And then minus 12 plus 24 is 12. So that just means that x is equal to minus 4 and y is equal to 12. And that's how we solve the system of equations using matrices. This concludes this question. Please don't forget to comment, subscribe, and like.